Hello everyone, I hope you all are doing good, and today we'll discuss about Newton-Raphson method. It's a method to find roots of an equation and it's an iterative method. Now this is the general formula of Newton-Raphson method. New value is equals to current value minus function of current value divided by derivative of function of current value. Okay, so now let's suppose an equation x cube minus x minus 1. Now just find the function and derivative of the function, and now just suppose two values of x 0 and 1 and put them in the function. Now we are having values of functions minus 1 and minus 1 respectively. So as you can see, there is no difference in sign of both the values. So we will again put a new value of x, which is 2. Now we are having the value of function, which is 5. Now as you can see, there is a difference in the values of function. One has the negative sign and other has a positive sign. Now we can suppose these two values of x, 1 plus 2 divided by 2 is equals to 5, because whenever signs are changing, so that means root lies between that numbers. So here root lies between 1 and 2 because sign are changing here, minus 1 and 5. So we will just add this 1 plus 2 and divide it by 2, and we are having our first root, which is equals to 1.5. Now put that 1.5 in the function, and in the derivative of function we are having some new values, and put all these values in our general formula of Newton-Raphson. So after putting it here, we will have our answer of first iteration, which is 1.34. Now again put this 1.34 in the function and derivative of function. We will have some new values. Now put all these values again in the formula, and then we will have answer of our second iteration. Now take a look at this code. In first line we have imported SymPy as SP, and what is SymPy used for? SymPy is used for mathematical stuff, which we are doing right here. And then we have defined our function, and we have 4 parameters. F is our equation, x0 is our initial guess, tolerance is set by default, and max iterations is also set by default. Now we are defining that x would be our symbol, which we will be using in our equation. So here we are defining our symbol as x. Iterations are set to 0, x underscore n equals to x0. And why we are doing it? Because we have to update this value of x underscore n by each iteration. Now while iteration is less than max iteration, okay, so f value, which is the value of function, is equals to, now just substitute the value x underscore n, which will be our initial guess, with let's suppose 1.5, in x of equation f. Okay, so that's what it's doing here. In f underscore prime underscore value, we are doing same thing but with the derivative of the function. So we first found the derivative, sp.def. It means find the derivative of function with respect to x, and then substitute the value of x underscore n in x. Okay, so that's what this whole line is telling us. And now we are just raising in value error if this condition is reached, which is value of derivative is less than tolerance, then raise value error. Okay, now here we are just using our general formula, which is x underscore n equals to x underscore n minus f value divided by f prime value. Now here we are doing x underscore n equals to round. We are a rounding of the value by 5 decimal points. Okay, so here we have 5 decimal points, and now we have one more condition, which is if f underscore value is less than tolerance, then just break the loop, and if none of the condition is true, then just increment in the iteration counter. And once we are out of this loop, okay, then just return x underscore n, which will be our final answer. Outside the function, we have just defined our equation here. So what is simplify doing here? Simplify is taking this string as an equation and just saving it in the variable equation. We have our initial guess, which is 1.5, and root will be our answer. Now in root, we are calling our main function, which is Newton-Raphson, with equation this. Okay, initial guess is 1.5 and max iterations I have set here is 4. Now if I run this code, it is giving me correct answer. And that's it for today, guys. If you really enjoyed this video and really got to understand something about Newton-Raphson method or the Python, then don't forget to like, share and subscribe. And that's all. Thank you.